Word problems involving a sine or cosine function, problem type 1. So you can see I can already have a problem here, so let's just jump right in. An object moves in simple harmonic motion with amplitude 9 centimeters and period 0.5 seconds. At time t equals 0 seconds, its displacement d from rest is negative 9 centimeters, and initially it moves in a positive direction. We're asked to write an equation modeling displacement as a function of time. The first thing I notice is that we are talking here about simple harmonic motion. Simple harmonic motion means a path described by a sine or cosine function. So I know that my displacement is going to be an amplitude times the sine or cosine, I'll put in sine as a placeholder because it's usually sine, of some constant related to the period times x plus a phase shift plus a vertical shift. In simple harmonic motion, it's usually a safe bet to assume that the vertical shift is going to be 0 because measuring based on the center point makes the most sense. In this case, I know that the amplitude is 9 centimeters. That's given to me directly in the problem. So A is 9. I know that the period is 0.5 seconds. And I know that in the equation of sine or cosine, the period is 2 pi over b. Right? So 0.5b is equal to 2 pi. I'm running out of room here. B itself must be 4 pi. So I can take b out of the equation and replace it with 4 pi. So now the only thing left to worry about is what is c going to be? And I guess there's always the possibility that I'm wrong in calling it sine. It might end up being cosine. And we can figure that out from this initial spot. At time t equals 0, its displacement from rest is negative 9 centimeters. In this particular case, that is as big as it gets, right? 9 centimeters is the amplitude. And for my displacement to be the amplitude, that means, well, it's negative, so that means that at 0, I'm looking at the trough of the function crossing the y-axis. In order for that to happen, I don't want sine, I want cosine. The phase shift is going to be 0. Let's move that parenthesis in, let it join everything else. And this expression like this would start me up here at the top. I need to be down at the bottom. So let's take a negative. You can test that. Look at the expression, analyze it, make sure it's what we say it's going to be. This is an equation that has an amplitude of 9 centimeters. It has a period of 0.5 seconds. And if I plug in t equals 0, I get d equals negative 9, which is exactly what the problem setup tells me is supposed to happen. So there's my equation to model this situation.